Hey guys, so welcome back. This is just this week's video of all the questions we did. Same just as always, if I've forgotten any, let me know. And if you want any specific ones done, just send them in and I'll try and include them in the next video, or I'll send you back a worked solution. Okay, great. So let's just jump straight in. So I think the first one we started with was, given that x is equal to 3 is a solution to the equation absolute value of x plus 5, or x plus p is equal to 5, we want to find the two values of p, where p is just an integer. And so this is just a positive or negative whole number, and we're trying to find the values of p. Okay, great. So words that stick out in this sentence is the word solution. So we know the word solution is another word for root, and we know that we tend to sub roots in and let's see that everything equals. And so let's just do that. We know that x minus 3 is the solution, so everywhere we see x, we're going to sub in minus 3. So absolute value of minus 3 plus p is equal to 5, and we want this to be true. Okay, and so when we're talking about absolute values, we know that there's a hidden minus sign, because if we're talking about absolute value, we're thinking about the number line, and we're thinking about distance from the origin. So if this is 2, this is also 2. And so the absolute value of minus 2 and 2 are the exact same thing. And so here, that means that the absolute value of minus 3 plus p is equal to 5, or it's equal to minus 5. Okay, great. And now we just want to find the values of p that make this true. So let's do that. So p is equal to 5 plus 3 is 8, and p is equal to minus 5 plus 3 is minus 2. And so when p is 8, this equation is satisfied, and when p is 2, this equation is also satisfied. But let's just check that and make sure we haven't made any mathematical slips. So minus 3 plus 8 is equal to absolute value 5, and the absolute value 5 is 5. And minus 3 minus 2 is equal to minus 5, and the absolute value of minus 5 is 5. So yeah, both of these are correct, and so we can keep both of them. And that is the whole question done. We found two values for p such that this is true given that x minus 3 is a solution. And we can also keep both of them because p is an integer. So it's positive or negative whole number. So these are both whole numbers and they're positive and negative. So we can keep both of them. And that's the whole question done. Another way we could have done this question is we can square both sides to kind of get rid of that minus sign, because we know any minus number squared is just going to be the same as itself times itself, and then the two minuses, so minus times a minus is a plus, and so this will just give us x squared. So when we square something, we make it positive and we get rid of the minus sign, so we actually get rid of the hidden minus sign that's associated with this absolute value if we square it. So we get minus 3 plus p squared is equal to 25 squared is, or 5 squared is 25, and minus 3 squared is 9, p times minus 3 is minus 3p, and then times 2 is minus 6p, and then p squared is p squared. And now we just have to solve a quadratic for p, get two values for p, and it should end up being, like we got before, 8 and minus 2. And then you'll have to check them, same kind of gist. This way it just takes a little bit longer because just how it is. So I prefer to do the other way, but if you can't think of it on the day, that's okay. You can go ahead and square both sides. Okay, great. So let's move on to the next question. Okay, so next one was the function f of x is equal to x over x plus 3 plus 3 times 2x plus 1 over x squared plus x minus 6. And we want to show that this function is the same as writing x plus 1 over x minus 2. Okay, and so this is just algebra, and we know that they basically want us to simplify into this. And we've done that before. Whenever we have two complicated fractions added together, we're going to try to simplify each fraction first, and then do the addition and try to simplify that then. Okay, great. So straight away we can see that we can simplify this by factorizing. So if we factorize it, x times x is x squared. I'm going to guess that 3 and 2 makes 6, and we want minus 6, so one of these is going to be minus. And we want plus 1 in the middle. So plus 3 minus 2 will give us plus 1 in the middle, and then minus 2 times 3 will give us minus 6. Okay, so this here can actually be written as x plus 3 times x minus 2 on the bottom. And the top well, that's pretty factorized already, so we can leave it like that. Okay, great. So when we're adding two fractions together, we know that we're going to cover up the one it's sitting on top and then multiply by everything else. And then we're going to do the same for this one. So let's do that. So, and then write everything over, then multiplied. So let's multiply our bottom two terms. And remember that we rewrote the quadratic as x plus 3, x minus 2. And so this is just these two terms multiplied together. Okay, great. Now we're going to write this term and multiply it by this because we're covering up what it's sitting on top of. So let's do x times x minus 3, or sorry, x plus 3, x minus 2, because this is, we factorize that. Okay, and now we're going to add this multiplied by whatever we're not sitting on top of, so it's x plus 3. So now let's add 3 times 2x plus 1 times x plus 3. Okay, great. And so we can see straight away that there's some things that we can cancel. So we can cancel these x plus 3's, so they're gone. And we still have one x plus 3 on the bottom. And so what we're going to do is, I'd say next step is probably just to, there's nothing else we can cancel, so let's just do the actual operation. So we're going to multiply x times x minus 2, and then add it to 3 times 2x plus 1. But we can do this straight away. If we multiply everything by 3, we'll get 6x plus 3. And then this over here is going to be x squared minus 2x. So we're going to add 6, so that's going to be 4x. And so we have x squared plus 4x plus 3. And let's see if we can factorize that, because it's a quadratic. So if we factorize it, x times x is going to give us x squared. 3 times 1 will give us the 3, and yeah, 3 times 1 will also give us the 4. How are we going to do that? We'll just add the 1 to the 3. So this can be rewritten as x plus 3 times x plus 1, and that's perfect because we can see that this x plus 3 will cancel with that. So what we're left with is exactly what they want. We have x plus 1 over x minus 2. And great. So we've simplified what f of x was equal to, and now we've written it like that, and that's all I want. Great. So on to the next part. So part 2 says, find the range of values of x for which f of x is less than 4, where x is less than or equal to 2. Okay, so this is f of x up here, x over x plus 3 times, or plus 3 times 2x plus 1 over x squared plus x minus 6. And we want to find the values for x such that that's less than 4. But we've already went through all this trouble to simplify down into this. So this and this are the exact same thing, so why don't we just let this be less than 4? And now it's much easier to find x. Okay, so let's do that. So x plus 1 over x minus 2 is less than 4, and we want to find x. Okay, so problem here is that x is above the line and x is below the line, and what we would normally do if this was an equality is just cross multiply by x minus 2, and now x is on the left hand side and x is on the right hand side. But because this is an inequality, we know that if we multiply both sides of an inequality by a minus number, we're going to have to swap the direction of the inequality. So to get around that, we're going to have to multiply both sides of an inequality by a number we know which is definitely positive. And the number we're going to pick is, we're going to multiply both sides by x minus 2 to be squared. And the reason we're going to pick this number is because this x minus 2 will cancel with one of these, and now x is just above the line, like this disappears, and now x is on the left hand side and on the right hand side, just like we wanted before. But we don't have to worry about swapping the inequality sign. Okay, so we've transformed the equation into this, and now all we need to do is just multiply out all our terms, add them all together, and see what we have. So x times x is going to be x squared, x times 1 is x, minus 2 times x is minus 2x, and minus 2 times 1 is minus 2. And that's going to be 4 times x squared is x squared, minus 2 times x is minus 2, times another 2 is minus 4x, and then minus 2 squared is plus 4. And so if we add these together, that's x squared plus x minus 2x is going to be minus x, and then minus 2, and that's going to be 4x squared minus 16x plus 16. Okay, so we have x squared terms, x terms, and constants. So we know straight away that this is kind of the building blocks of a quadratic. And so what we're going to do is, when we're solving quadratics, is get a 0 on one of the sides, factorize our quadratic, and figure it out from there. Okay, so let's let the 0 be on this side, just because our x squareds are going to be positive that way. So 4x squared minus x squared is going to be 3x squared. Minus 16 plus x this time is going to be minus 15x. And 16 plus 2 is going to be 18. So now, before we factorize this, we can actually simplify it. So if we divide everything by 3, that's going to be x squared minus 5x plus 6. Now if we factorize x times x is going to be x squared. And 3 times 2 is going to be 6. And does that work for our middle term? Yeah, 3 and 2 will give us minus 5 if we do minus 3 minus 2. And that works perfect because minus times a minus gives us the plus then for the 6. Okay, great. So this basically means another way of writing this quadratic here is x minus 3, x minus 2. So x minus 3 times x minus 2. Great. So we basically want to find values for x. And now how we could do that is if we look at this whole thing together, multiplied together, this whole thing multiplied together is going to be positive because it's greater than 0. And the only way a number is positive if it's two things multiplied together is if it's positive times a positive, or it's a negative times a negative. And so we could go through each of our cases. We could say case 1, both of them are positive. Oops. Positive. And then case 2, both of them are negative. Or a quicker way we could do is, if we actually look at the shape of our graph, it's going to look something like this. Actually, if I kind of make it squatter, and I go like this, sorry, and I'll just make that. Okay, so it's going to look something like this, stretching off to infinity this way and this way. And where is it going to cross the x-axis? Where are our roots going to be? Well, we can figure that pretty easy from our factors. If we let each factor equal to 0, then we can figure out where the quadratic is going to be equal to 0. So x is going to be 3 and x is going to be 2. So here is going to be 2 and here is going to be 3. So these are the roots for our equation. And why does that help us? Well, basically, we want, this is where the equation is equal to 0, and we want everything greater than 0. So we want everything above the line. So everything this side and everything stretching off to infinity this way. And what does that mean for x? Well, that means that x is going to be to the left of 2 here, because 2 is where x was 0. So everything left of 2, it's going to be x less than 2. And everything to the right of 3 is going to be x greater than 3. And so now we just have to merge these together. And a little trick I told you to do that was write x on opposite sides. So if we swap this around, this is the exact same inequality. And if we see x is here on my left-hand side and x is on my right-hand side, if we write them then on top of each other, like this, and you smash them together, you get 2 is less than or greater than x is greater than 3. Now, so we found a range of values. Let's go back to our question, see if we finished it. We found a range of values for x for which f of x is less than 4. We've done that, but it's also where x is less than or equal to 2. So here we have x less than 2, but it's saying that x can also be less than or equal to 2. And so now our question is finished. So if you have a piece of information in the question that you haven't used, you probably need to use it. They don't like to throw things in unnecessarily. Sometimes they might do it to give you different options on how to do the question, but by and large, if you've left out a piece of information, you've definitely forgotten about it, and you might have something small like this. Like people would get like 8 marks out of 10 or whatever, that kind of thing, high price for credit. But if we want to go for full marks, then we got to include this less than or equal to sign. Okay, great. So that's that question done. Takeaways would be multiplying by something we definitely know is positive, and then how to solve for x in an inequality. And that the easiest, fastest way would be to draw a little graph, little sketch, and then figure out if it's above the line or below the line, and what that means for x and its roots. Okay, great. So we'll move on to the next question. Okay, so next question says, find the solution set for the following inequality where x is any real number and x is not equal to 3. Okay, so we can see here this is pretty much the second part of the question we just did. We're trying to find x, but x is above the line and x is below the line. So what we would normally do is multiply across by x plus 3, but we have this inequality in the way. And so what we're going to do instead is multiply by x plus 3 to be squared. And that's going to be greater than 1 times x plus 3 to be squared. Okay, so one of these is going to cancel with one of those, so it'll disappear. And 1 times anything is just itself, so now we just have to solve this equation. So how are we going to do that? Well, we can multiply everything out. So x times 2x is going to be 2x squared, times 10 is 10x, 3 times 2x is 6x, and 3 times 10 is 30, greater than x squared. 3 times x is 3x, times 2 is 6x, 3 times 3 is 9. Okay, so now we have our quadratic and we want to get a 0 on one side and find out what our values for x are. Let's put the 0 on this side just because our x squared will be positive. So 2x squared minus x squared is going to be x squared. At 10x, let's merge these together first. 10x plus 6x is 16x. And then we're going to minus a 6x off, so that's going to be 10x. And then 30 minus 9 is going to be 21. Okay, so now we just have to solve this quadratic. X times x is going to be x squared, and 7 times 3 is going to give us 21. Will that give us 10 in the middle? It will, because we can just add on 7 and 3, and that'll give us plus 10. And does that work for 21? Yeah, plus times plus is going to be a plus, so that works perfect. So another way to write our quadratic is x plus 7 times x plus 3, and we want that greater than or equal to 0. Okay, so like before, we can go through our cases and say that both the multiplied together are greater than 0. That means this one's positive, or this one's negative, and this one's negative. But a quicker way to do that we saw was if we draw a graph, we draw our quadratic. Where is it going to cross the x-axis? Well, x is going to be minus 7 here, and x is going to be minus 3 here. So it's going to be minus 7, minus 3. And we want where, so this is where the thing is equal to 0. This is where our quadratic is equal to 0 at minus 7 and 3, and we want greater than or equal to 0. So we want everything above the line. So everything up here stretching off this way, and everything up here stretching off this way. And so what does that mean for x? It means if this is where it's equal to 0, then everything to the left of this is going to be greater than 0. So x is here is going to be greater than or equal to, or sorry, less than if we're going to the left. So less than or equal to minus 7. And we're including the equal to because it's like this, equal to there. And so if everything's to the right of minus 3, it's going to be x greater than or equal to minus 3. So how are we going to write these together? Well, if we write our x's on opposite sides and then smash our x's together, we're going to get minus 7, blah, 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 and this. And this is our final answer. Now, we're still not finished because x cannot be equal to minus 3. And why that's important is because here we've written x is greater than or equal to minus 3. But they told us that it can't be equal to minus 3, so we're just going to drop that. Okay, great. So now our question is finished. And this is the final answer, so we're going to move on to the next one. So it says, solve the equation 3 to the power of 2x plus 1 minus 28 times 3 to the power of x plus 9. Okay, so what we're going to do is, this looks fairly complicated, and what we're basically going to do is, we see a term here we see another term multiplied, and then we see a constant, and we know that's equal to 0. So what this should kind of remind you of is a quadratic formula. And so if we can somehow turn this equation into a quadratic formula, we know how to solve quadratic formulas, and we can solve the quadratic formula and then do whatever we did backwards and turn it back into this. Okay, so how are we going to turn it into a quadratic formula? Well, for a quadratic formula, we want x squared, some kind of x, and some kind of constant. And so here we have a constant, so that's pretty easy. Our constant's going to be 9. Here we have some, I should have put an a here. So we have some number times an x. Here we kind of have that. We have a 28 times something. And then here, it's just a bit complicated. We'll ignore that for a second. But what this kind of might lead us to believe is that if we let x equal to 3 to the power of x, then we're going to have something times whatever x we have, a constant, and then we can worry about turning this into some kind of an x squared. Okay, so what we're going to say is we're going to get let x or y, let's use y because we kind of already have an x. So let's say y is equal to 3 to the power of x. Okay, so now this is going to turn into a y. This is going to be our constant. So we're going to have 3 to the power of 2x plus 1 minus 28y minus 9 equal to 0, or plus 9 equal to 0. And okay, now our next job is worrying about turning this into some kind of y squared. Now how are we going to do that? Well, we know y is 3 to the power of x, so let's try turn this into something expressed in 3 to the power of x. And how we're going to do that is using our rules for indices, which are in your log tables. So the first rule we're going to use is that something to the power of something plus something else is actually just going to be the exact same as that base times the power of the first term, and then multiplied by the base times the power of the second term. And then we're going to keep our substitution that we made already, so that's 28y. And now we're getting closer. We can see there's a 3x hidden in here somewhere. But how are we going to get there? Well, we know that multiplication doesn't matter which way you do it. If you do 2 times x or x times 2, we're still going to get a product of 2x. And so why don't we just write this as x times 2 instead of 2 times x. Okay, now we're getting really close. We see a 3 to the power of x, but now we have an x2 up here. So we're going to use another rule for logs, and that's going to be if you have a base to the power of anything multiplied by another thing, that's actually going to be the same as the base to the power of the first one, all to the power of the second one. And then don't forget about 3 here. So 3 to the power of anything to the power of 1 is just itself. And then we can have 28y plus 9 equals 0. Okay, great. And now this is perfect. We have a 3x. We know what 3x is equal to. 3x is going to be y. So y squared times 3 minus 28y plus 9 equal to 0. So y squared is just going to be y, and then times 3 is going to be 3y squared minus 28y plus 9 equal to 0. And now we successfully have our quadratic. We know how to solve quadratics. And what we can also do is probably divide by 3. So 28 divided by 3 is going to be, oh no, that's not divisible by 3. Anyway, we'll just leave it like this. 3y times y is going to give us 3y squared. And maybe 3 times 3. 3 times 3 will give us 9. Will it give us minus 28 in the middle? 3 times 3 is 9. We can't really get an 8 in the middle. So why don't we do 9 and 1? Will that give us 28? It will give us 28, but if we swap these around. So 3 times 9 is going to give us 27, and then if we add on a 1, we're going to get 28. But we want minus 28, so we're going to do minus 27 minus 1. And does that work for our plus 9? We have minus times a minus, so that's going to give us plus. Yeah, works. So our quadratic can be written as 3y squared. That quadratic can be written as 3y minus 1 times y minus 9 and equal to 0. And so if both of them multiplied together equal to 0, that means at least one of them is equal to 0, if not both of them. So we can just set both of them equal to 0 and see what values for y that gives us. So if 3y minus 1 is equal to 0, then y is going to be 1/3. And if y minus 9 is equal to 0, then y is going to be 9. So we've gotten two values for y. So back to our game plan, what we did. We couldn't solve this complicated equation up here. So what we did was we did something and we turned it into a quadratic. Then we solved the quadratic. But now we need to make sure that whatever we did, we're going to undo. And what we did was we let y equal to 3 to the power of x. And so what we should do down here is kind of do the opposite of that. We're going to let 3 to the power of x equal y. So 3 to the power of x is going to be a third, and 3 to the power of x is going to be 9. Okay, so we want to find x. If our x is stuck up in a power, the opposite of raising something to a power is taking a log of it. So what we're going to do is take log to the base 3 of 3 to the power of x equals log to the base 3 of 1/3. And so log to the base 3 of 3 to the power of x will just cancel with 3 to the power of x, and we're left with x. And log to the base 3 of 1/3 is just going to be a number. And if I get out a calculator, it's going to be, sorry. Log to the base third is going to be -1. Okay, and so over here now we're going to solve this one. So if we take log to the base 3 of 3 to the power of x equals log to the base 3 of 9, this is going to cancel with this. We're going to be left with x, and log to the base 3 of 9 is going to be 2. So we found out x is going to be -1 or x is going to be 2. And so have we finished the question? Yeah, we've solved the equation, so we found the values for x such that that's true. Okay, and that is the whole question done. And so on to the next question. Okay, so next question says, find the two values of m for which 5 plus 3m is equal to 11. And so we know from the very first question we did today that when we're dealing with absolute value, we know there's a hidden minus sign. And so we can use this to advantage because if 5 plus 3m is equal to 11, that means, if absolute value of 5 plus 3m is equal to 11, that means it could be plus or minus 11. And so if we split these into two equations, that's going to be 11 and minus 11. And now we just need to solve for m. So getting m on its own is going to be 11 minus 5 is going to be 6. And then dividing by 3 is going to be 2. And then getting m on its own over here, that's going to be minus 16. And then dividing by 2 is going to be minus 16 over 3. And that is the whole question done. Another way we could have done it was if we squared both sides of the equation. That means if we square both sides of the equation, then the hidden minus sign disappears, and we don't have to worry about it. So if we square both sides of the equation, we'll get 5 plus 3m squared is equal to 11 squared. And then we square everything out, we'll get a quadratic in m, then find the values for m. So same deal, we're just getting, in one technique we deal with the minus 11, and in the squaring technique we just get rid of it and we don't have to deal with it anymore. Okay, so part B says, for real numbers h, j, and k, express k in terms of h and j. Okay, so if we want to express anything in terms of anything else, it basically means getting this thing, the thing we're expressing, alone on one side, and then letting it equal to the things that we want to express it in on the other side, plus anything else that doesn't have a k in it. Okay, so let's do that. We want to express k, so let's get k on its own on one side and get anything with h and j on the other. Okay, so problem here is that k is above the line and k is below the line, and here we're not dealing with an inequality, so what we can actually do is go ahead and just cross multiply like we would normally do. So 1 times j plus k is equal to h is equal to k. Anything times 1 is just itself. Okay, and so now we're left with j plus k over h. So problem here is that we have k on the left hand side and the right hand side, but this k over here is above the h, so we can't really get it out of there unless we multiply across by h. So let's do that. Let's multiply across by h. So now we have j plus k is equal to kh. And if we want to get anything on its own on one side, well, then we have to get everything that it's involved in on the same side. So let's get all the k's on one side and all the j's and h's on the other. So it's going to be kh minus k. We're just bringing that k over there. Okay, so now we have k's on all one side, but we want to get it alone on one side. We want to express k in terms of h and j. And right now we're expressing k and h in terms of j, or we're expressing j in terms of k and h. So we need to get k on its own over here. And how we're going to do that is, well, we can see that k is a common factor here. So if we actually just take k out of the equation, so k times h will give us kh, and k times minus 1 will give us minus k. So now we're left with j equals k times h minus 1. Problem here is that something is multiplied by our k. So what we can do is just divide both sides by whatever the problem is. Now we have k is equal to j over h minus 1. And now we've expressed k, so we've gotten k on its own, and all the h's and j's on the other side. And that is our whole question done. So the reason I threw this question in was just because algebra is kind of the backbone of maths. And a lot of people get scared when there's no more numbers involved. But the rules for algebra apply whether you're a number or a letter. It doesn't matter what you are. Rules of algebra always apply to you. And so people see this and they get scared. They don't know how to do. But just use the rules you've always been using this whole time. If something is above something else, multiply it across. If something is multiplied by something, just divide across. Take the highest common factor, that kind of thing. But yeah, pretty simple question, but people sometimes fall down right at the start. They don't know how to start it. But yeah, rules of algebra, that's the takeaway. Rules of algebra apply to everything. Okay, great. So we'll move on to the next question. Okay, so next question says, solve x squared plus x minus 10 less than or equal to 10 for all x. So x can be any number. Okay, so this is very similar to the questions we've been doing before. We can see that we have x squared terms, x is in constants, so that means we're dealing with a quadratic here. And our technique for dealing with quadratics is to get a 0 on one side, and then factorize the quadratic, solve for x, and then see what range of values we need. Okay, so why don't we let the 0 be on this side, just because all we have to do is take the 10 away. So if we take the 10 away, we're going to be left with x squared plus x minus 20, and we have the 0 on that side. So now we're going to factorize, so x times x will give us x squared, and 5 times 4 will work because 5 times 4 is 20, and 5 minus 4 is 1. So plus 5 minus 4 is going to give us 1. And will that work for our minus 20 here? Yeah, because a plus times a minus is going to give us a minus. So our quadratic can be written as x plus 5 times x minus 4 less than or equal to 0. Okay, and we'll keep doing what we were doing before. If we draw our quadratic graph, it's going to look something like this. We're going to have, where does it cross the axis? Well, it's going to cross it at minus 5, and it's going to cross it at 4. So this is going to be minus 5, this is going to be 4, and we want everything less than 0. So if this is where the quadratic is equal to 0, then everything below the line will be where the quadratic is less than 0. So what does that mean for x? Well, if it's below the line, it's going to be everything to the right of minus 5, because that's kind of the crossing over point. So everything to the right of minus 5 means that x is going to be greater than minus 5, and we have this equality sign there. So that means we also want to include where the quadratic is equal to 0. So that means we have to include minus 5 as well. So x is equal to, or greater than or equal to minus 5. Okay, and so if everything is to the left of 4, that means it's going to be less than or equal to 4. And so now we just have to write it as one big one. So how we can do that is if we write them on opposite sides. Yep. So here our x is on the right hand side, here our x is on the left hand side, and we just write one above the other. If this will work, there we go. Write one above the other, put your x's together. So x is less than or equal to 4 and greater than or equal to minus 5. Or we could write this another way. We could say minus 5 is less than or equal to x is less than or equal to 4. And so that is our whole question done. We don't need to, we've solved the equation, so we've gotten values for x, and this is for all x, any x. So we don't need to worried that x is less than or equal to 5 or greater than or equal to 5 or less than or equal to 4, it can be that. Okay, perfect. So that's B done. Now on to part C. So part C is a little bit difficult. It gave us some trouble during the week. But basically our technique, so we want to prove that a squared plus b squared is greater than or equal to 2ab for all values of a and b, an element of, so a and b are just any numbers. Okay, and so our technique for proving anything to do with inequalities is basically going to be trying to get a 0 on one side of an inequality and something squared like an x plus b squared on the other side, because we know that anything squared, any number squared is going to be greater than or equal to 0. 0 squared is just going to be 0, so that's equal to 0. And then 1 squared is 1. Minus 1 squared is also 1. 2 squared is 4. Minus 2 squared is 4. So everything's greater than or equal to 0. So that's our kind of technique. So why don't we take a look at what we have and try to get that. So we see that we have a squared plus 5b squared is greater than or equal to 2ab. Okay, so we want a 0 on one side. Probably the easiest side to get the 0 on is this side, just because we only have to minus the 2ab. So let's minus the 2ab, and that's greater than or equal to 0. Oh, also, yeah, we'll pick this side just because this is the way our inequality is facing, and we want our square number to be greater than or equal to 0, because that's how it works. Okay, yeah. So how are we going to turn this into a square number? Well, we know that when we square anything, we're going to square the first, so we end up with like if we have x plus 3 squared. This is just an example now, separate to it. So if we square the first, we're going to end up with x squared, and then we multiply we multiply by 2 the product. So we do 2 times 3 times x, and then we square the last. So this is the exact same as this, and you see here that we have a squared term at the front, a squared term at the end, and a product term in the middle, so two things multiplied together. So what if we go back up here, we see that we have a squared term, and a product term. So let's write them like we just saw. If we write them as a squared term, a product term, and then a square term, well, now we could maybe try to figure out something, an a squared, an a plus a something b squared, that will give us a minus 2 in the middle. The problem is that there's no kind of even numbers. If we try factorize this, a times a is a, 5 times 1, or 5b times b is 5b squared, but we can't really get a minus 2ab in the middle. So what we're going to do is try turn this into something we can work with. And something we can work with is a squared minus 2ab plus b squared. And then plus 4b squared will give us the 5b squared. So we've just split up that 5b squared into b squared plus 4b squared. And why we've done that is because this is a very famous kind of collection of terms, because this is always a plus b squared. And you can even see that if you know it, you can just write it down, but you can see that if you try factorize, a times a is a squared, b times b is b squared. And how are we going to get the minus 2ab in the middle? Well, a times b is ab, a times b is ab, and we're just going to minus them off each other. So minus 2ab minus 2ab, or minus ab minus ab will give us minus 2ab, and that's exactly what we want, minus 2ab. And does that work for our plus there? Yeah, because a minus times a minus is a plus. Okay, and so this factorized would be a minus b times a minus b, and that's the exact same as a minus b squared. Okay, so now we've dealt with this first part. Now we just got to deal with this 4b squared. So we've done this part. This is definitely positive. We know that. We don't know if this is positive yet, so let's try to figure it out. So we have a minus b, and how are we going to do this? Well, if we see that 2b squared will just give us 2 times 2 is 4, and b times, like, you see what I mean? 2b times 2b will be 4b squared. and so this whole thing is squared, and so now we have something that's definitely positive, something that's definitely positive, and a positive plus a positive is going to be positive as well. So now we've proven that it's definitely greater than 0, QED. All done. So takeaways from this question is that when we want to prove anything to do with inequalities, we're going to try to get a 0 on one side and say that a square number is always greater than it. And so just the little catch here is that we need to recognize that we can't actually factorize this. And so what we're going to do is turn it into something we can factorize and then deal with whatever added on, or whatever is added on at the end. Okay, I think our next question is another proof question, so let's just jump straight into that one and we can get to grips with it more. Okay, so the next question says, part C, or C part 1, prove that x plus 9 over x plus 2 is greater than or equal to 4, where x plus 2 is greater than 0. Okay, so we want to prove that 9 over x plus 2 is greater than or equal to 4. And so, like I said before, our technique for kind of proving anything to do with inequalities is to kind of get 0 on one side, so we get it over here, and then get a perfect square over here. And we know that anything squared is greater than or equal to 0. So let's try to do that. Okay, problem here is that we're adding something to do with x and something to do with x, but here the x is below the line. So what we would normally do is, because it's an inequality sign, we'd normally multiply by whatever is below the line squared, because then we know one of those will cancel with one of those, and we won't have to change the inequality sign. But the problem with that is, if we multiply everything here by x plus 2 to be squared, we'll end up with x times x plus 2, 9 times x plus 2, greater than 4 times x plus 2 squared. And this half, we've done before. We've done similar questions like this. Imagine it's like this. We're multiplying by x plus 2 squared. One of those will cancel, and we just solve from here. But the problem is, over here, we're going to end up with x times x squared plus whatever, and we're going to end up with x cubed. X times x is x cubed plus whatever. And if our goal at the end is to turn it into something squared, that's particularly hard. We can do it with cubes, but it's particularly hard to do it with a cubic. So we know that what we've done is we've gone down a wrong path. And what we did was we multiplied by x plus 2 squared, but we know that's not going to work because we're going to end up with a cubic. So we're kind of back to the drawing board, and we need to figure out what to do here. And we know that when we hit a kind of wall in a question, we need to go back to the question and use something that they've given us. And they've told us that x plus 2 is greater than 0. And so what that means is, this is positive. It's greater than 0. It can't be equal to 0 because we're dividing by 0, obviously. But that means x plus 2 is positive. So what that means is, why do we multiply by x plus 2 squared? We multiply by x plus 2 squared because we know that's definitely positive, but now they've already told us that this is positive. We don't need to worry about multiplying by something that we make positive because this is already positive. So let's multiply everything by x plus 2. And now that's completely positive. So we can leave the sign the way it is and then multiply by x plus 2. This will cancel with this, and we're just left with 9. And now we just have to multiply it out. So x times x is x squared. And then x times 2 is 2x plus 9, greater than or equal to 4x plus 8. Now if we bring everything to one side, x squared, 2x minus 4x is minus 2x, 9 minus 8 is 1, greater than or equal to 0. And we factorize x times x is x, 1 times 1 is 1. That'll give us the 2 in the middle if we minus them off each other. And then that works because a minus times a minus is a plus. Okay, great. This are going to be our factors, and we can see we have the exact same factors. So we have x minus 1 and x minus 1 greater than or equal to 0. And another way to write that is x minus 1 squared. Anything multiplied by itself is squared. And so now we've done what we wanted to do. We have something squared is definitely positive, and we have that greater than or equal to 0. So that's the whole proof done. QED. Okay, so why don't we move on to part 2? So part 2 says prove that x plus 9 over x plus a this time is greater than or equal to 6 minus a, where x plus a is greater than 0. Okay, so x plus 9 over, instead of 2 this time we have a, and greater than or equal to 6 minus a. So they're, again, same kind of trick. They've told us x plus a is greater than 0. So we know that we can straight away multiply by x plus a. And I'll skip a step here because we know this is going to cancel. So that'll be 9. And it would be x plus a, but then it'll cancel. So we're just left with 9. And then 6 minus a times x plus a. So let's do the same thing. Multiply everything out. X squared plus ax plus 9 greater than 6x plus 6a minus ax. 6x plus 6a minus ax, and then minus a squared. Okay, so now let's get everything on one side, because we want to have a 0 on one side and a perfect square on the other. So 6ax minus 6a minus 6x plus ax plus 9 minus a squared greater than or equal to 0. So I just swapped all the signs here and brought them to the other side. So we have, just make sure I haven't done it. Okay, so x squared ax, we changed that, minus 6x, then we change that, ax, then a, then that would be plus ax. There we go. Okay, so we want to turn this into a perfect square. It all looks a bit messy, but we see that we have terms, similar terms. So let's add those together. So we can add an ax and an ax. So that'll give us x squared plus 2ax. Then we're going to have a 6a and a 6x. We can't add them. Then we're going to have a 9 and we're going to have an a squared. That's a 9. Okay. So let's bring like terms together. So let's bring everything with an x over here. And then we'll write everything with an a. It's a 9. Okay. And so we see that, okay, we have what looks like here a quadratic in a. And we have here something that almost looks like a quadratic in x. So what we can do is we're going to try to turn these into two quadratics and then find the perfect square. So let's like this, and this will create a quadratic in x. So x times x is x squared, and 3 times 3 is 9, and that'll give us the 6x in the middle. Okay, perfect. So we've dealt with the x squared, the 6x, and the 9. So that leaves us with the a squared plus 2ax minus 6a. Okay. So I think might have gone wrong somewhere because we have an x here that shouldn't be. How are we going to get around that? Okay, so we seem to have made a mistake because we've successfully turned this into a perfect square. So we have x minus 3 squared, but we can't do anything with this because we have an x here and everything else is a's. So why don't we kind of go backwards a little bit and see what else we can do. So one thing we could do is, because we were stuck with this x here, this ax, why don't we take out x as a common factor from, what was it, 2a and this x, this 6 over here. So that'd be 2a minus 6. Okay, and then we're left with 6a plus a squared plus 9. Okay, and so now if we're left with, let's rewrite a little bit. So x squared plus x times 2a minus 6. And this looks like a quadratic but without a constant. So let's add our constant there. see where that takes us. And then we're left with a squared minus 6a. Okay, so, and that's greater than or equal to 0. I'll just take a second here to make sure all my numbers are right. So, or my signs, a squared positive a squared, yeah, okay. Okay, so why don't we try, oops. Okay, we have the first two terms of quadratic. So let's turn this into some kind of perfect square. Okay, we have another squared 6a plus 9. This looks like it'll work because it's a times a is a squared. And again, like we had before, 3 times 3 is 6. And so this can be rewritten as a minus 3 to b squared. Okay, so we're getting somewhere. We have one thing in a perfect square. So now let's see if we can turn the rest of it into a perfect square. And this kind of looks like a quadratic. We have an x squared, an x, and some kind of constant without x. So let's just try factorize it. X times x is x squared. A minus 3 times a minus 3 is a minus 3 squared. And does this work for our middle one? Well, x times a minus 3 is xa minus 3a. And then if we add xa minus 3x there, that should be. That'll give us 2xa minus 6x. Oh, perfect. And then, yeah, we take the xx, 2a minus 6. And that's exactly what we wanted in the middle. Okay, so this surprisingly works. So, what did we do? We added those. And so now, our quadratic can be rewritten as x plus a minus 3 to b squared, greater than or equal to 0. And now we have something that's squared, so it's greater than 0, and greater than 0. So, QED. So that's the whole question done. That one was a bit more tricky. But same thing, like we were saying before in our letters question, just because the letters are here doesn't mean we can't factorize and use our rules of algebra the exact same. So everything stays the same, just a bit trickier in trying to get to link certain numbers together and see what fits. And but yeah, like we were doing, just keep trying, keep messing around. If we think we've gone too far and we ended up stuck, one thing is to go back to where we knew we were kind of on the right path and go back to there. Okay, so you've gotten that question done. And things like this take practice. The more times you do them and the more often you see them, the easier it becomes. So my advice is, if you're looking at this question and you think, geez, I'd never be able to do that, well, you can see that even I'm tripping up a little bit, but don't let that discourage you. Just if you trip up and you get to somewhere that ends up not making sense, just go back to a previous stage and start again. Okay, so we'll move on to the next question. Okay, so our next question was to do with logs, and this is kind of a typical logs question you can get, or an exponential question even, which is kind of the opposite of logs, like we know. So yeah, let's just jump straight in. So it says the relationship between the number of bacteria in a petri dish, BT, so that's the number of bacteria, and the time elapsed T is given by this formula: B of T is equal to AEBT, where A and B are just any numbers, and at time equals 0 hours, 100 bacteria are placed in a favorable growth medium. Okay, so things that stand out: T equals 0 hours, 100 bacteria. So let's just take a highlighter, highlight that. Actually, I think I have a highlighter. Take a highlighter, highlight that. And then next thing, 6 hours later, 450 bacteria. And so it's asking us to show that BT can be represented by B of T is equal to 100E 0.25068T. Okay, so basically they want us to find A and they want us to find B. And how we're going to do that is we're going to use what they give us in the question. Okay, so it says if time equals 0 hours, our function is going to be this, so AEB b and 0 for t. And we know that 0 times anything is 0, and 0 to the power of anything is 1, and 100 bacteria. So our output, b of 0, even I'll do it this way, b of 0 is going to be 100. So now we know that a times 1 is just a, and a is 100, and that's exactly what we wanted. Okay, great. So now we know that b of t can be represented by 100 instead of a, and then e, b, t. Okay, and so we've hit a wall, and we need to go back to the question and see what we can use. So 6 hours later, 450 bacteria are present. So 6 hours later from t equals 0, so that means t is 6. And this is 100 e to the b times 6. And that was equal to 450 bacteria. Okay, we want to find b, so let's divide by, our b is up in the e, so let's divide by this 100 and multiply this b by 6, b6. So 450 divided by 100 is 4.5. And our b is stuck up in the e, and we know that the opposite of e is ln. So if you take ln of both sides, this will cancel with that, and we're left with 6b is equal to ln 4.5. And then we can just divide by 6. So b is equal to ln 4.5 divided by 6. And I can guarantee you that that is going to be equal to 0.2506t. Okay, and so b says how many bacteria will be present after 10 hours. So we know bt is equal to, we just found out it was equal to 100 e to the 0.256 or 068 t. And so now we want to find b after 10 hours, so t is 10, 100 e 0.25068 times 10. And this is just a number we can plug into our calculator, and that'll give you some kind of decimals. Okay, so next it says, how long will it take for 15,000 bacteria to be present? So we know that our output at whatever time t is, we can even change this to x. So sometime x, bacteria left is going to be 15,000. And we want to find when that happens. So we know this happens at EB 0.25068 times x. And we want to find x. Okay, same kind of thing we did before. We're going to divide by 100. So 15,000 divided by 100. E 0.25068 x. Dividing by 100. Just drop 2 zeros. So 150. Then we can take log E of both sides. 0.25068 x. This will cancel with that. So ln 150 is equal to 0.25068 x. And to find x, we just have to divide across. So ln 150 is 0.25068 x. And this, again, is a number we can plug into our calculator. Okay, so that's the whole question done. Very typical question you can get. And I think our very last question is very similar. So let's jump straight into that. Okay, and so our very last question is another similar question. It's to do with a function with an exponential in it, and we're going to have to use logs. Okay, so it says a heated metal ball is dropped into a liquid. As the ball cools, its temperature T degrees Celsius, T minutes after it enters the liquid is given by this function here. Okay, find the temperature of the ball as it enters the liquid. So things to highlight, enters the liquid. So we know it's dropped into the liquid, so as it enters the liquid, it's going to be right as it goes in. So that means that T here is going to be equal to 0. So capital T, our temperature, at T equal to 0 should be 400 e to the minus 0.05 times 0 plus 25. And we know from the last question that this is all just going to end up being 1. And then we're going to add 25. And 1 times anything is itself. So we're left with 400 plus 25, which is 425 degrees Celsius. Okay, so that is the temperature as the ball enters the liquid, right at the initial temperature. Okay, now we want to find the value of T for which the temperature is 300. So we know T of X, let's call it, is 300. And we know that's given by 400 e to the minus 0.05 x this time, plus 25. So we want to get x, it's stuck up here, so we need to kind of undo everything that's been done to it. So first it's being multiplied by minus 0.5, then it's being raised up into an e, and then it's being multiplied by 400, and then it's added, at 25 is added. So let's do everything in reverse. So let's take the 25 off first. So it's going to be 275 equals 400 e to the minus 0.05 x. Now we want to divide by that 400. Divide by 400. And then we're going to take the log of both sides. This again, so log of everything, that's going to cancel with the e. And we're going to be left with minus 0.05 x. And then we just want to divide by minus 0.05. And that will give us our time x. And so that's going to be just some number that we can throw in. Okay, and so the very last question I gave you was, if the ball is left in the water until it is fully cooled, what is the lowest temperature to which it will fall? So things to highlight here is the ball is left in the water. So if you think about it, at what time x is the ball left in the water? If we put the ball in at time 0 and we leave it there, what is the time? So the time when we leave it in there is going to be infinity, because we're leaving it in there forever. And we want to see how low the temperature goes. So T here is actually going to be infinity. So if we take, what was it, 400, capital T of infinity, it's going to be 400 e to the minus 0.05 times infinity plus 25. Okay, and so infinity, when you're multiplying things, has similar rules to 0. If you multiply anything by infinity, it's still going to be infinity. And if you multiply infinity by a minus number, it's going to be minus infinity. So e to the minus infinity plus 25. We know anything to the minus number is just itself, 1 over itself, to the same power, but this time it's plus. And now, if we think about it, this is where some people get stuck. But if we think about it, if you think about a half, and then a third, and then a quarter, if we think about this on a number line, say we have 0 and 1, then we have a half, then we have a third, then we have a quarter, then we have an eighth, or a fifth, sorry, whoops, then a sixth, and so on and so on. So you can see as the number here gets bigger, 2, 3, 4, 5, 6, this way we actually get smaller and smaller and closer to 0. So that means if our number down here is really, really, really big, that means we're going to be really, really, really close to 0. And anything to the power of infinity is going to be infinity. And so if this is really, really close to 0, and it's really, really close, we can just say that it's 0. And so 400 times 0 is 0, and then we add the 25. So this, the lowest temperature to which it will fall if we leave the ball in there forever is going to be 25 degrees Celsius. Okay, so that is that question done. Reasons I included this was just kind of this last part, that sometimes they throw in questions to kind of separate things. Like, obviously this is a fairly guaranteed question, not guaranteed, but fairly common question to be asked on a Leaving Cert paper. So then they threw this bit in just to kind of see who really understands it. Okay, so yeah, I think those are all the questions we did during the week. Same thing as always. If I've forgotten any, please let me know. And if you want anything specific done, just send it into the WhatsApp. But I'll leave it there, and I'll see you guys next week.